Okay, so we'll start. Good evening, everyone. I am Nalin Vilochan Mishra. I am one of the TAs for this course, A Brief Introduction of Microsensor. This course is taken by Dr. Shantanu Talukdar. He is Assistant Professor in ISA Bhopal. This is my last tutorial for week 4. It's week 4. Today we'll cover basic numericals for piezoresistive pressure sensors. Okay. So first of all, we will start with defining piezoresistivity. So okay. So what is piezoresistivity? So, when the electrical resistance of a material changes its response to mechanical stress, then this phenomena is called basically piezoresistivity. Okay, so let me write it. When the electrical resistance of a material changes its response to mechanical stress, then this phenomena is known as piezoresistivity. Okay. Okay, so we will discuss some design constraints. So design consideration of a piezo-resistive pressure sensor. Sorry. Okay. So we know that resistance R is equals to rho L by A, where rho is the resistivity of the material. Hi guys, can you hear me? Like, is my voice audible and my video is clear? Can you please type in the chat box or something so that I know? Yeah, thanks. Okay. So as I was saying, rho is the resistivity of the material. L L is the length of the material, and A is the area. And area can be rewritten as W times T, where W is width and T is thickness. Okay. So when the resistor is subjected to strain, what will happen? So when the resistor is subjected to strain, there should be some change in the resistance. Okay. So the relative change in resistance can be given by, so when I talk about relative change, it means that I'm talking about delta R by R. Okay, so I need to calculate this. So what is delta R? Delta R is change in resistance. So if I assume R1 is the resistance when no strain was applied or no force was applied, it's the same thing, and R2 is the resistance after the application of strain or stress or force, then R1 minus R2 is basically delta R. It can be positive or negative. Okay. So similarly, delta rho is change in resistivity. Delta L is change in length. Delta W is change in width, and delta T is change in thickness. So these things happen because of the application of strain. So what you need to do, you need to calculate this value, change in R by R, where you know the formula for R, it's rho L by A, and change in R can be written as change in rho, change in L, change in A, which is change in W, and change in T. So you need to find the ratio. So how can we do that? So we are calculating change in R by R. So for calculating this, first we need to write R, which is basically rho L by omega or WT. Then both side both side take log. So it will be log R is equals to log rho L by WT. It can be written as log R is equals to log numerator minus log of denominator. Further, it can be written as log rho plus log L minus log omega or W minus log T. Then you need to differentiate this. Differentiating this equation with respect to R. So it will be, what is the differentiation of log R? It is 1 by R dou r by dou r, we can write it like this: 1 by rho, sorry, 1 by rho d rho by dou r plus 1 by l dou l by dou r minus 1 by w dou w by dou r minus 1 by t dou t by dou r. We can cancel this dou r. So finally we'll have dou r by r dou rho by rho plus dou L by L minus dou W by W minus dou T by T. Or we can write it like this: delta R by R is basically dou rho by rho, or change in resistivity by resistivity, plus change in length by L minus change in width by width minus change in thickness by thickness. Okay, so that's how you can calculate change in R by R. Okay, so this is the equation we'll use in numericals. I'm giving it equation number 1. Then this change in width by width can be written as this: change in L by L, where this V or mu is basically Poisson's ratio. Also, it is equal to delta T by T. We can write this delta L by L as strain. So we can replace delta W by W is equals to delta T by T is to minus mu epsilon. So this is equation 2. Okay. Now there is one more thing, gauge factor. So by formula, it's change in resistance by resistance upon strain, where this is change in length by length. Okay. So putting equation 1, putting equation 1. So basically expression of this change in R by R, change in R by R in gauge factor in 3. So we'll get, what we'll get, G is basically change in R by R by epsilon. So we can write it like this: change in r by r, and change in r by r can be written as this. Sorry, change in row by row plus change in L by L minus change in width by width minus change in T by T. Also, we know that this change in L by L can be written as strain, and these terms change in width by width and change in thickness by thickness can be written in terms of strain as um, like this from equation 2. So finally we'll obtain this. We can divide this strain. So finally we'll have change in rho epsilon rho plus 1 plus 2 nu, equation 4. So do you guys have any doubt till here? So we have this formula of change in resistance from equation 1. We have this formula which relates change in width by width, change in thickness by thickness with strain. We have this gauge factor, and we have this relation also. Okay, so let us try some numericals. The change in resistance of an electrical strain gauge with a gauge factor of 2 and resistance of 50 ohm when subjected to a strain of 0.001 is. So you need to determine the value of delta R. Gauge factor is given, the value of resistance is given, and the value of strain is given. So tell me the answer. It's a very simple formula based question. Which formula will you use? I think this one, equation number 3. So this is the week 4. So did you like this course? How did you find this course? It is interesting or anyone got the answer? Have you guys registered for the exam? Answer is zero point 0.1 ohms. Yeah, correct. Anyone else? Okay. So let me do it. Course is interesting. Yeah, it's very interesting course actually. So this TA ship, so online live interaction, is this useful for you guys? Like, is this adding something for your learning or it's not? It's not. It's of no use. Oh, okay. You registered also. So you guys attend all the three sessions or only one of the? Yeah. So you guys attend all the three sessions on which happens generally on Saturday, Monday, and Tuesday, or one of the three live interactions. Generally, what you guys do? Okay, okay. So which week you find most interesting? I think on week 1 we learn something about basic mechanics. In week 2 we saw some capacitive calculating capacitances, capacitive sensors. In week 3 we learn about etching, and in week 4 we are learning some case studies like piezoresistive sensor, pressure sensor, accelerometer, gyroscope. So which week was most interesting for you guys? Okay, so let's solve it. So the formula for Gauge vector is given by change in R by R on strain. The value of strain is given, value of R is given. We need to calculate the change in R. So it can be rewritten as this, and then so the value of R is coming out to be zero point 0.1 ohms. Okay, let's move to next question. Yeah, me too. Actually, we three TAs, me, Amay, and Vaishali, we discussed among ourselves. So I'm mainly focusing on the numerical part. So that's why in all weeks you have. Do you guys see the recording session which I post on YouTube? So if you see that, you will see I only cover the numerical parts. Amay mostly covers the assignment problems and Vaishali covers both assignment and numericals. So we are trying, yeah. So we are trying to cover all the things which can come up in exams. So yeah, thanks for the feedback.
Yeah, I'm actually driving at the moment, so I can't provide you much feedback. I'm only on the listening mode at the moment.
Yeah, sure,
So,
sure.
so,
Actually, this was the yeah.
so very good efforts. Because personally, I am working in semiconductor laboratory Mohali, so I have some knowledge about this thing.
Mm-hmm.
So, but it has been very descriptive.
Mm-hmm.
So, and the content, because I believe you start from the very basic.
Mm-hmm.
And the other sir, I forgot his name, Amul or something like that.
Yeah.
He covers like most of the assignment part or related to that.
Mm-hmm.
And Vishali touches both
Yeah.
conceptual as well as the numericals related to the assignment.
Mm.
So I think you all three are like covering up as a whole, and plus that is very much additive to the lectures provided by sir.
Yeah.
So thanks for this. You are
Good.
providing a very detailed perspective of all the angles related to the course.
Yeah. Thank you, Mitu, for your lovely feedback. Thanks. Okay, so let's move to the other question. So, resistive strain gauge, where the value of G is given as 202, is cemented on a rectangular steel bar with Young's modulus of value 205 into 10 to the power 6 kilonewton per meter square. The value of width is given as 3.5 centimeter and thickness is 0.55 centimeter. An axial force of 12 kilonewton is applied. So you need to determine the change in resistance, which is basically change delta R, if the value of R is given as 100 ohms. So please try to do it. Okay, so how can we do it? The same formula we will apply here also. Change in R by R upon epsilon. So gauge factor multiplied with strain multiplied with resistance can give us the value of change in the resistance. Here the value of G is given, R is given, but we need to find the strain. So the basically question is to find the value of strain. So if we are applying the force axially in this steel rod, we can calculate the value of stress. Stress is given as force by area. We know the value of force. Force is how much? 12 kilonewtons. Area is width times thickness. It will come out to be 62.3 into 10 power 3, and epsilon, this strain, can be written as stress upon Young's modulus, and it is coming out to be 0.304 into 10 to the power minus 3. Then G, so the value of G is 202 multiplied with this epsilon value 0.304 into 10 to the power minus 3, and resistance is 100 ohms. So finally, after solving it, the value of change in resistance is coming out to be 0.067 ohms. Okay, so let's move to the other type of questions, which is basically piezoresistive pressure sensor. Here, assume the maximum deflection omega naught of a square membrane of thickness h and side 2a takes place at the center of the plate and is related to applied pressure P pi. So basically, there is this square membrane which has the thickness h and side of 2a, and there are these four resistance which are placed like this. Let us name it R1, R2, R3, and R4. So R1 and R3 are basically placed perpendicular to the edges, and R2 and R4 are parallel to the edges. Okay, so when we apply a force, it will have the maximum deflection omega naught, and the pressure P is related. So the formula of P is given by Young's modulus H by A to the power 4 G1 omega naught by H plus G2 omega naught by H the whole cube is the general formula, where we have both linear and non-linear terms in here. Here the value of G1 can be written as 4.13 by 1 minus nu square, and value of G2 is 1.98, 1 minus 0.585 nu by 1 minus nu. Generally, the value of G1 and G2 are material dependent and always given in the question, or the value of Poisson's ratio is given so that you can calculate it. This is important thing. The burst pressure which is defined as the maximum pressure at which the diaphragm ruptures. Basically, this that is square membrane. So it is given by sigma max was to burst pressure PB by A by H square, where this is basically the maximum stress. So this burst pressure is related to the maximum stress. There is another formula for change in R by R, which is given as sigma L pi L plus sigma T pi T, where these pi L and pi T are the longitudinal and transverse piezoresistive coefficients. The value of sigma L is basically P A by H square, and sigma T can be given as this. This is longitudinal stress, this transverse stress. Or if the direction of force is reversed, then maybe it can be written as this. Okay, so we'll see in the numericals how it works. So if we apply these things in this equation, then we'll get, here you can assume pi L is equal and opposite to pi T, and hence finally we'll have change in resistance by resistance pi L P A by H square, should take it out, and 1 minus nu. This is also a very important formula for the numericals. Okay, so this diagram, yeah, this one. This can be modeled in electrical parameters such as resistance in Wheatstone bridge form, like this. If we apply V in one of the terminal, assume there are four legs of the resistance and it is joined like this. So in the middle we can calculate the output voltage. Here you can also note that these four resistances R1, R2, R3, R4, the way they are placed, so that when we apply a force and when this diaphragm deflects by omega, so there is change in resistances. The change in resistance can be increase in resistance or decrease in resistance. So this R1 and R3 generally has increment in resistances, and R2 and R4 has decrement, so it the value is decreased. And so we have these values, r plus del change in r plus change in r, this value is negative and this value is also negative. Okay, so when diaphragm is subjected to pressure, the imbalances created in the bridge, which results in output voltage V naught. So V naught is given by change in resistance by R multiplied with input voltage. So this change in resistance by R multiplied with input voltage. If we put the value of change in R by R in this equation, we'll have P A by H whole square 1 minus mu pi L V in, or pi A by H whole square 1 minus mu pi T V in, where V in is the bridge supply voltage. One more thing, we have sensitivity. So the sensitivity is defined as the relative change of output voltage per unit change of applied pressure, something like this. S is equal to change in V naught by change in V, or we can write like this: S is equals to change in R by R. So this is the most used formula for the numericals. And the unit is generally millivolt per bar or millivolt by volt bar. These are the unit of this sensitivity. Okay, so based on these things, let us try some numericals. Okay, Mitu, there are so many formulas whether related to the calculation of constant K for various beams related to restriction and sensor exposure. Do we need to learn all the formulas completely by heart, or there is some possibility of sharing the formula with some twist with the numerical in exams? Okay, so I would not suggest you to learn these formulas. What you can do, you can practice as many numericals as you can, so that there are, like in beam case, there are only two or three numericals for coefficient, stiffness coefficients. The formula, so all the formulas are basically logical only. Like the case of capacitance, we have epsilon A by D. So if there is any change in the distance D, so it should be D minus Z or D plus Z only. So these numericals, like these formulas are, like in this piezo resistive, there are some numeric formulas you need to learn. I agree, but it is only for week 4. But all the other weeks, I don't think there are so many formulas. You can easily like remember it if you practice some numericals. That's what I feel. And I don't think they will, in exams they will give you some formulas. They can, but you should remember all the formulas. So please practice as many questions as you can. You can follow some books. You can mail me. I'll suggest some books. I have some materials. I have some numericals. I can share it with you apart from these things, because for my session I only have these 2 hours, and in 2 hours I need to cover the relevant theory with numericals. I try to cover only the numerical part, but there are these numeric these formulas, so I need to revise you guys. So that's why I'm deriving these numeric formulas. Okay, so let's go to the question. So for a diaphragm of thickness h and sides of length 2a, so you need to find first the burst pressure, second the maximum pressure up to which a pressure sensor works in the linear range of operation. The third part is determine the sensitivity of piezoresistive pressure sensor. The values which is which you need to use in this numerical are GL value is given as 100, the value of GT is given minus 100, sigma max is given 7 gigapascal, the dimensions are h is equals to 5 micrometer, a is 250 micrometer, g1 is 5.9. I don't think you need G2 because only linear range of operation is required. The Poisson's ratio is zero point 0.3. So please try to solve. You only need these formulas. This, this one, and yeah, mainly this one. Okay, please try. You guys try. I'm coming in 2 minutes. Oh, my screen is gone. Can you see the shared screen right now? Yeah, okay. Okay, thanks. Okay, so anyone solved it? Any part? Was the value of burst pressure? Okay, so burst pressure can be written as sigma max by A by H whole square. So it is coming out to be 28 bar, where 1 bar is basically 10 to the power 5 Pascal. This is part A. Part B is the maximum pressure up to which a pressure sensor work. Okay. So the pressure can be written as E is equals to Y H by A to the power 4 G1 omega naught H plus G2 omega naught by H to the power 3. But in the question, it is asked only in the linear range of operation. Hence, this part is gone. We can ignore this non-linear term. So T can be written as Y G1 H by A to the power 4 W naught by H. Here the value of G is given as 5.9. This value is for silicon. So we can put the values. After solving it, you will get the value of Vmax, which is 0.16 bar. I hope you guys are also getting the same answer. The third part, it is asked determine the sensitivity of piezoresistive pressure sensor. So sensitivity is basically change in R by R multiplied with change in P. So change in R by R can be written as GL 1 minus mu sigma, right? By change in P. Also, this strain can be written as this, and the value of stress can be written as PA by H whole square. So, putting these two values in this, we'll get sensitivity is GL by Young's modulus 1 minus Poisson's ratio A by H whole square. And after solving it, we'll get the numerical value as 1.2102.5 millivolt per bar. Okay, so let's move to the next question. An N type square membrane having side 2A equals to 500 micrometer and thickness H is equals to 10 micrometer is used in a piezo resistive pressure sensor. The P type piezo resistor with R is equals to 1 kilo ohm determine the change in resistance, which is basically delta R, the sensitivity when 10 to the power 5 Pascal or 1 bar pressure is applied. The numerical values are given. G is 100, Poisson's ratio is 0.3, Young's modulus of silicon given as 170 gigapascal, and input voltage is 1 volt. Please try. Okay, so we know that Gauge vector is given by change in R by R upon strain. So we need the value of change in R. That can be calculated as this, and we can write the value of stress as P by A h square 1 minus mu 1 by y. From here, we can calculate the value of strain by putting up the values. The numerical answer for strain is coming out to be 2.7 into 10 to the power minus 4. We'll put this value in here. So after solving, the value of change in R is coming out to be 25.7 ohms. The second part can be easily calculated. Sensitivity can be written as change in R by R P. This value of change in R by R you already know, and the value of P you also know. So the answer is 25.7 millivolt per bar. Okay, please try this next question. A piezoresistive pressure sensor has dimensions zero point 0.5 mm cross 0.5 mm and thickness of 5 micrometer. The resistors are arranged in a conventional manner. So determine the first part is the maximum pressure up to which the sensor can be used, so that the condition is given that P max is 1 by 5 P burst. Here take the values. Y is 170 gigapascal. Sigma max is given, which is 5 gigapascal. Poisson's ratio is given as zero point 0.2, and GL is equals to minus GT is given as 100. Use these values and calculate the maximum pressure up to which the sensor can be used, so that P max is. So what you need to do, you need to calculate the P burst value. P burst can be calculated corresponding to sigma max. Sigma max, you already have the formula, which is P A by H whole square, where you can calculate the value of P burst, then divide it by 5 and you have P max. So please tell me what you are getting numerically. Okay. So as I was saying, sigma max can be given as P burst A by H whole square. The value of sigma max is given as 5 gigapascal. P burst is unknown, and the ratio A by H you can calculate, which will be 2500 after squaring it. Please keep this in mind that this dimensions. So if I am telling you it is zero point 0.5 mm by zero point 0.5 mm, then the value of 2a is zero point 0.5, not the value of a. So a will be 0.25. So please keep this thing in mind. Okay, so P burst will come out to be 10 to the power 6 Pascal. Since in the question P max is given as 1 by 5 P burst, hence P max is zero point 0.4 megapascal. Okay, the second part is draw the top view of membrane with the resistors on it and determine the output voltage of this pressure sensor of an input voltage of 1 volt, and the application of pressure is basically given as zero point 0.1 bar. 1 bar is 10 to the power 5 Pascal. So you need to draw the top view of this membrane, which has these 4 resistors on it. Okay, so let me draw it. So it's like this. This is a square membrane where we have these four resistors like this, four strips of resistor. These resistors are connected with each other, something like this. Okay, now let me mark also, this is a membrane or diaphragm. These blue things are resistor strips, and these are connected with some conductor or some wires, and this is further extended like this, and it is connected to, or it is anchored like this. So it's the top view. The top view look like this of piezoresistive pressure sensor. The second part of this question was, uh, we need to calculate the output voltage. So sigma L can be calculated as this. So it will come out to be 25 into 10 to the power 6 Pascal. Sigma T is basically related with Poisson's ratio, and it will be 5 megapascal. The change in R by R can be written as uh, Poisson's no gauge factor multiplied with strain, and strain further can be written as this. I think we have calculated this here, this one. Okay, so change in resistance by resistance, by putting the values you will get 0.011764, and the output voltage is related by this formula. So after putting this in here, V naught will be 0.0111118 volts. Okay, the third part of this question is, you need to determine the deflection W naught of the diaphragm at a pressure of 2 bar. Assume only linear region. So we can write the formula for pressure as this. Sorry, it must be 4. The value of G1 can be calculated from this formula. So it is coming out to be 4.3. So after putting all the values, the pressure is 2 bar. The value of A is 0.25 mm and the value of H is 0.05. Please note the unit, like match all the units so that you'll get the correct answer. It is 170 gigapascal and H is 0.005 by 4.3. After solving it, you will get the value of omega naught 8.55 micrometer. So please try this next question. If the effective longitudinal piezoresistive coefficient of silicon is given 60 into 10 to the power minus 11 Pascal inverse, what will be its gauge factor? Here, assume Young's modulus as 170 gigapascal. So what are they asking? They are asking for longitudinal piezoresistive coefficient, which is pi L. No, the value of pi L is given. Sorry, the value of pi L is given if the effective longitudinal piezoresistive coefficient is given as 60 into 10 to the power minus 11 Pascal inverse. Then you need to calculate gauge factor. The formula for gauge factor we know, it's del R by R by sigma, which is strain. We also know that change in R by R is sigma pi L. If only longitudinal force is applied. So put this value and determine the final value of G. Please tell me the final value of G. What are you getting? So I hope you guys got the answer for this. So this can be written as, if we put this value sigma pi L, and if we take out this strain and put at the RHS, then it will be like this. We know that Young's modulus is written as the ratio of stress and strain. So the value of G will come out to be this. Here the value of pi L is given 60 into 10 to the power minus 11, and the value of Y is also given 170 gigapascal. So after multiplying it, we will get the value of G as 102. Okay. Find the applied pressure in pascals so that a square silicon membrane of side 200 micrometer and thickness of 10 micrometer deflects by 2 nanometer. Here Young's modulus is given as 170 gigapascal. So what are they asking? They are saying that find the applied pressure so that the square silicon membrane, if we if it deflects, so it will deflect in the direction of inside the paper. The reflection is given as 2 nanometer. The thickness of this square membrane is 10 micrometer. The value of 2a, this side is basically 2a, so the value of 2a is given as 200 micrometer. From this we can calculate the value of a as 100 micrometer. So we have a, we have omega, w naught. Also I think g1 you can take it the value as 4.54. So you need to find the pressure. The formula for pressure is this. G1, please put the values and let me know the answer for P. Find the applied pressure so that a square silicon membrane of side 200 micrometer and thickness of 10 micrometer deflects by 2 nanometer. Anyone has solved it? Okay, so P The value of Young's modulus is 170 gigapascal. The value of thickness is 10 micrometer. The side A is 100 micrometer. The value of G1 for silicon is 4.54. The value of W naught is 2 nanometer, and the value of H is 10 micrometer. And after solving it, you must get 15436 Pascal. Please convert this unit in micrometer so that it's uniform. And giga is 10 to the power 9. Okay, so I think I have the last question for today. So please try it. A fixed free cantilever is made of single crystal silicon. Value of G is 50. The dimensions are: length is 200 micrometer, width is 20 micrometer, and thickness is 5 micrometer. Here, if the force F of 100 micronewton is applied at the end of the cantilever in the longitudinal direction. So the force is applied in the longitudinal direction, not in the transfer direction. So the question is, what would be the percentage change of resistance? So the force is axial force. It is acting in the longitudinal direction like this. If we draw the beam, it's like this, where the thickness T is given as 5 micrometer, the width is given as 20 micrometer, and the length of this beam is given as 200 micrometer. Here we have this piezoresistive element fixed with this beam. This is basically a piezoresistive element. It can sense the percentage change. It is for sensing. So please tell me what would be the percentage change of resistance? How can you calculate it? We know that percent change in R by R is basically G times strain. You can use that formula where the value of strain you need to calculate. And how can you calculate strain? Strain you can calculate as stress by the Young's modulus coefficient. So finally you need to calculate the value of stress. Stress is given as force by area. The value of force is given, area you can calculate. So that's how you can reach to the change in R by R value. So please do it. I have given you the hint. Please try to do it. Anyone got the value of at least strain? How can you calculate strain? Or the value of stress? Stress is force by area. How much area are you getting? Area is nothing but, okay. So first, the first step is you need to calculate force by area. The value of force is already given as 100 micronewtons. Area you can calculate. So this area is required. Area you can calculate as no, not this area, because we are applying force in this direction. So this area, omega times T. Yeah, so it will be omega times T, because we are applying force in this direction. So area would be omega times T. What is the value of omega? Omega is 20 and T is 5. So it is 100 micrometer, and sigma is 1 megapascal. Stress or strain is related to stress as this. So the percentage of strain is coming out to be 0.00077%, and change in resistance by resistance can be written as this from this formula. change in R by strain, and after putting it, the value of G is 50 and strain is coming out to be this value. We have 0.038%. So the percentage change is 0.038%. So this is the final answer. Okay. So this is it for today. Uh, this was my last TA tutorial session. Best of luck for your examinations, and you can feel free to text me or mail me. My mail ID is nalin20 at the rate iserb.ac.in. You can mail me your queries. You can also WhatsApp me 7974151035. You can WhatsApp me the questions. I'll try to help you. Okay? Okay. See you soon. Best of luck for your examinations. Bye.